Hello and welcome to HXGN TV, the online video channel for Hexagon's global network of brands. I'm your host Shruti Khanna, and today we are discussing the metrology challenges facing the aerospace industry with Steve Fletcher, Head of Business Development for Aero Engines at Hexagon Manufacturing Intelligence. Thanks for joining us, Steve.
Well, thanks for inviting me. It's been really interesting, exciting.
Let's start off by looking at some of the key drivers in the aerospace industry, Steve. What kind of trends and challenges do the aerospace manufacturers face today?
Well, the challenge now is that the aerospace industry's engines have never been quieter or more fuel efficient than they are today, but there's new developments in materials, cost reduction and weight reduction in the actual components themselves to make them lighter. Fuel is the biggest cost for any airline, so there's a challenge for the airlines to push the engine development to become lighter, more fuel efficient. They want to keep their engines in the air longer, and they want to be able to maintain them globally and support them globally. So that's the biggest challenge that we've got.
And Steve, specifically within the Aero Engine sector, what big changes are we seeing today?
Well, there's a whole host of themes that Hexagon are underpinning that technology, from advanced manufacturing, from advanced machining, forming, pressings, things like that, also into joining, and not necessarily from advanced inspection and systems integration. How do we tie all that information together and support those activities in machining, putting measurement at the right place at the right time?
Could you also explain to us a little more about what are the manufacturing processes that the aerospace industry sector is now focusing on?
Well, a lot of it is machining. It's the forming. How do I make components lighter? How do I use different materials? Composites is becoming a big factor in the aerospace industry because of their ability, not because they're lighter, they are in some respects, but they also can be formed into very more complicated surfaces. The use of additive layer manufacturing or 3D printing is becoming more apparent within this industry. There's a challenge with that technology as to how do I support that? How do I ensure that that process is valid and I can put it onto an engine? Existing technologies take a long time to migrate away from because of the confidence and the understanding of that component and that material. To change that is you need to go through a whole validation process, which is not something the aero industry takes lightly. Unlike automotive, there is no hard shoulder at 30,000 feet, so we have to ensure that the components that go onto them will be right first time and will be performing as they should be doing, with the safety aspects and also the performance issues that these things are driving.
Could you also explain to us a little more about the kind of people or the skill sets that we require for this industry? And as we see today, there's been a marked change in the skill sets of people, hasn't there?
There is people is the fundamental. There's four major areas: people, standards, systems, and technology. And people are the forefront of that. The development of people in that area is key. Their roles are changing because of more automation. Their skills are being raised because of they're engaged with more integrated solutions. So that's very important. And how do I control that from a global manufacturer? I want to have the same skill sets, something I can monitor, something I can audit, something I can progress and support globally. It's not just local training. They're looking to have standardized solutions and people that can be deployed from one side of the globe to the other side of the globe and perform in the same way. And so that's a big challenge to the aerospace because it's something that they've never really been involved in the past. And raising their competencies of the people is kind of one of the big prime movers within.
So like many other industries, the aerospace industry is also trying to reduce on inspection.
Yes.
So this could be some kind of difficulty for the metrology manufacturers. So what is Hexagon Manufacturing Intelligence doing for this?
I think that puts a fear in any manufacturing that manufactures coordinate measuring machines or any measurement devices, but the reduction in measurement is not necessarily they don't want to measure anything, is that they want to measure more intelligently, and they want to look at controlling their processes more. The journey from aerospace is very much come from a crafted industry. We've made things fit, and then we've spent a lot of time in measuring 100% to understand why they fit. And we're now moving into a volume manufacturing because people want to fly more. So we're looking to say, how do we get more components in the air, more engines on aircraft? So that really demands more volume. So how do we look going from 100% inspection into a process controlled solution and also back into a design driven solution that data is fed back into there and shared across the manufacturing space. So that's where data is. It's more intelligent data. So it's not reduction, it's just the better use of that information.
These days we hear a lot about various topics like the digital arena, we hear about the big data, industry 4.0. How are our manufacturers from the aerospace industry, taking to the latest technological trends and advancements, and are they ready to embrace them?
It's something that's been embraced already within the aerospace industry. Engines are monitored from when they leave the runway to when they get back onto the runway, and so there's a lot of telemetry data that's already been recorded. What the big challenge is within Industry 4 and the big data is, how do I decipher that information into usable bite-sized information that people can make judgments on, that is also linked back into what happens to the component when it's done 30,000 hours in an aircraft. It looks completely different to something that's been manufactured in an industrial plant. So where can data be used, and what's the environment in which they do? So there's all these key things that are being part of that big data model that they want to look at, saying it's not just dimensional, it's other information that can control the process, to understand more about the part itself, how that part is functioning as within the engine, and also what does it look like when after it's been manufactured and after it's been used, and how can we share that information back into design to make more intuitive parts, really.
Okay, so keeping these ideas in mind, how is Hexagon Manufacturing Intelligence actually helping our aerospace manufacturers solve some of their industry issues?
Well, we're engaging with them not just at the quality level, we're engaging them within the whole systems architectural people, within design space, because if you don't embed embed manufacturing or measurement at your design stage, you can't actually use it within the process itself. So how do we sort of look to facilitate some of those? We have a number of sensors, which is, in some respects just a tool that's delivering very, very good, meaningful data that's validated within the process. But how do we share the data so people can decipher that information and make judgments on? And that's not just sort of saying, well, this is right or wrong, or it's a sorting process, but giving data to control the process, to understand how that process is being managed, what the effects on that feature has on the design. How do we look at more measuring just features, but whole surfaces? And also things like defects. Is there a defect on a component? How do we manage that? Where is it on the component? Is it really important that there's a defect? And also the different uses of materials now becomes a thing. So we're looking at sensors that can detect whether there is a crack or whatever, and we want to embed that within a common delivery of software and products that can be deployed and supported globally. That's the big challenge we're doing. And Hexagon are very well positioned to do that because of the array of sensors and the array of software that we have got. It's the challenge for us is how do we manage that to meet our customers' expectations.
As you have already mentioned, Steve, aerospace is an industry that has always been evolving. So how do you think, or what are the further changes that we will see in this industry in the next 5 years?
I think a lot of it is going to be more automation because of the numbers of engines that are increasing. There is a requirement for coming from this crafted to a in-process inspection. There's going to be more involvement within the supply chain. So how do we manifest ourselves into the supply chain and supporting that and the activities within that world? There's going to be more embedded measurement in the manufacturing process itself rather than the end of the line. Currently, a lot of the processes within measurement becomes a scrap detector. Is it right or is it wrong? Well, it's too late then because of the materials are very expensive and my rework process is very expensive to manage. So if I can make the components right first time, then it makes my whole cost efficiencies greater. So this is the challenges. How do I embed more of that manufacturing intelligence within the aerospace industry and how do they use that data in a more meaningful way? That's the challenge.
Thank you. Thank you so much,
Thank
Steve,
you very
for
much.
joining us today.
Thank you very much.
We would like to thank our guest Steve Fletcher, and for more information on Hexagon Manufacturing Intelligence, visit our website hexagonmi.com. And for more on HXGN TV or to watch additional episodes, visit the website hxgntv.com. Thanks for watching.